and the main life was it's a method that we use to determine optimum values of a function subjected to constraints and expressed as inequalities. In this definition, akuyang'ana kwambiri ma-constraints. Akuyang'ana constraints. Constraints are challenges amene munthu umakhala nawo whenever you want to challenges amene munthu ungakhale nawo whenever you are trying to achieve a certain objective. So, sorry, just a moment. So those challenges are represented as my inequalities. So in simple terms, linear programming, a method that is used to determine optimum values, function, which are subjected to constraints, are expressed in linear inequalities. So by inequalities, I think for Form 3, I have a lesson on that one. Yeah, you may check YouTube channel janga pa Facebook nabang explain. So we will use my inequalities whenever we are trying to deal with my problems or kudzana linear programming. So in practice, mostly when you want to optimize, you optimize my profits, you can optimize the volume, you can optimize the space, you can optimize a number of things. In engineering optimization, you can optimize my values that you want to use to achieve a certain goal. So, for us to do well in this linear programming, we have to know how we can formulate linear inequalities. And these linear inequalities mostly are represented by symbols. Symbol yamba imene ndiya greater than, symbol yachiwiri ndiya less than, symbol yachitatu ndiya less than or equal to, symbol yomaliza ndi greater than or equal to. So yeah, like from there, sorry. Yeah, so those four symbols and define my inequalities. So inequalities they represent my constraints, my challenges. Munthu angathe nawo kuti apange achieve a certain objective. So challenge yoyamba, you can have more zinthu zambiri zimene uli nazo komano cannot fit a certain space. That's a challenge. Or you can have a lot of money, but you don't know how can you use that money to effectively achieve a certain output, kind of profit. That's a challenge. That's a constraint. Constraint in the less than. In real life situations, you will always face my issues. You don't have enough money to achieve Jinajak. But with the little money that you have, with linear programming, can help you to achieve more output with the little that you have. Then you can have another symbol, your linear inequality. It's less than or equal to, which means it can have less than or equal to. We are let's say you have 20. Less than or equal to, mukuyenera kuyambira pa 20 po kumatsika m'munsi. Less than mukuyenera kuyambira pa 19 kumatsika m'munsi. And the other part in the greater than or equal to, the same thing. So you can have more things. So you start from the same value minimum which one. Yeah, so sorry. Yeah, so this one, let's move on. And this one, let's move on. Just a moment, I'm meeting a little challenge. So let me sort out that challenge. Let me sort out that challenge. Scrolling. Okay, let me just use this one. Yeah, so tonight by so basically that's the explanation immediately now from that table. Here, let's look at an example. How do we formulate these linear inequalities? How do we formulate them? Yeah, so we'll begin by looking at this example. We'll just get that example. Let me screenshot it and go to I'll just take this example. Yeah. So let's use PowerPoint. If you have any question, just put up the message. I'll be able to go through it and possibly stop and respond to that question. Yeah, so yeah, so now we have this example. This one. Okay, I think I can write. I hope we are able to see my writing. So we have that example. She's going to went shopping to buy sweets and biscuits. A single sweet cost 8 kwacha and a biscuit cost 12 kwacha. He had 100 kwacha to spend. He had to buy at least 5 sweets and less than 4 biscuits. Write down the inequalities to represent this information. So the first thing in this is to understand the question. How do you understand the question? Parima issues are ma concentrates. Concentrates kapena limitations. What are your limitations in this problem? The first limitation you only you only have 100 kwacha that you need to spend. Okay? You only have 100 kwacha that you need to spend. That's a concentrate. That's a limitation. Because you could have 200 kwacha, you could have 500 kwacha, but you have 100 kwacha, which means you have to manage whatever you have within the range of 100 kwacha. So another one, we have another one. You have to buy at least 5 sweets. So whatever you're buying per 100 kwacha, you should at least buy masweet or sajapira 5. Commerce. Another thing, you should buy my biscuit, Komano Jebera, 4 biscuits. Now, Baba, you have a concentrate, that's a limitation. You have another limitation, immediate parts. Then now, you have to represent such information into inequalities. I'll stop a little bit to give you time to think over this problem. I'll stop a little bit. I'll give it 2 minutes so that you can think. Look at those concentrates and possibly write somewhere and see if you can have the inequalities that we need, the inequalities that we need to produce from this statement. If you're done, just put up an okay symbol, messageable, and I'll see, then I'll proceed. Oh, okay, great. So, choyambirira tikunena kuti you have to know my concentrates, and those concentrates needs to be given a name, needs to have a name, needs to be known, okay? Needs to be known. So in this case, we have 2 things that we have to buy, and those 2 things that we have to buy, we have sweetie, that's number 1. Another thing that we want to buy, we have biscuit. And sweetie, ili ndi mtengo wake. Sweetie modzi akugulitsa 8 kwacha. Biscuit imene akugulitsa 12 kwacha. Komano whatever he buys zisadutse 100 kwacha. Whatever Chikondi buys zisadutse 100 kwacha. So that's the way to think about it. Now, because linear programming is an optimization method that helps you to get more sweets and more biscuits from 100 kwacha. What combination can you use to achieve more? That's what we want to achieve from this one. That's what we want to achieve from this one. So we have sweets, which cost 8 kwacha. We have biscuits, each cost 12 kwacha. But Mutui and 100 kwacha. Now, from this 100 kwacha, how many sweets should this one buy? How many sweets? I mean, how many biscuits should this one buy? To make sure that wagula zinthu zokwanira zochulukirapo, okay, using the same amount of money. Now, this sweet has to be represented by a letter. Can be any letter. You can say, let's say sweet should be X, biscuit should be Y. Okay. Let's say sweet should be X, biscuit should be Y. Now, in this scenario, to know he has now things that are determining what the concentrate a carry less than, a carry more than, kapena ikhale less than or equal to, kapena ikhale more than or equal to. So for us to determine that, we have to understand chizungu tsopano mmene chalembedwera. He had to buy at least. It means zinthu zosachepere bajani pa nambala yathu. Okay, so he had to buy at least 5 sweets. So at whatever this guy does, zinthu zake zosachepere 5. So pa inequalities zosachepera 5 zikhale 5 kapena zosachepera pa 5. So it will be greater than or equal to 5. This one is the first inequality, linear inequality that we get from here. The other one is whereby we are saying afunga agure ma biscuit, and we are representing my biscuit in the value ya y. And the second one, we are saying it should be less than 4 biscuits. So y should be less than 4 biscuits. So these are the 2 inequalities that we can have from this equation. Now we are remaining with one inequality. It's very important to determine how much we may need. Okay, so whatever this guy buys, okay, should not be greater than 5, that's sweets, and the biscuit should not be less than 4. So if you multiply 5x, that is, yeah, then you add 4. This one should not exceed ndarama imene ali nayo. So if you multiply 1 sweet, just a moment. Yeah. Sorry, let's clear here. I think there is a mistake. Tukunena kuti shouldn't be greater than 5, should be less than 5. So the cost is sweet in the 8 kwacha. So we are representing x as sweet. So to know the total cost of the sweets that this guy can buy, so we are saying x should be multiplied by 8 plus the total cost of biscuit that this guy can buy should be y times the value of 12. So this is the total money that this guy can have from this combination. Now, this total money should not be more than, should be less than or equal to 100. 100 kwacha. So muika kuti kodi maswiti angati apa, muika mabiscuit angati apa. So whatever you are doing should be within this range. So reaching this far, we now have 3 inequalities. The first inequality, your sweets should be greater than or equal to 5. The second inequality, your biscuits should be less than 4. And the third inequality is the total cost that you can spend, the total amount of money that you can spend. So in this case, you can only have total number of sweets, which is x total number of sweets, which is X, you multiply by cost, which is 8, plus total number of biscuits, which you might buy, you multiply it by the cost, but all that should be less than 100 kwacha. So, in other words, from this explanation, you can not spend more than 100 kwacha. You go to a shop, you want to buy my biscuit, you want to buy my sweet, but you don't know how many biscuits should you buy, you don't know how many sweets should you buy, but you have 100 kwacha. So another way of doing that is to make sure that, okay, let's say you can say, kunyumba kwanu muliko tingoika tingonaka muliko anthu 10. Pa anthu 10, mods, anthu 5 afuna ma sweet, anthu 4 afuna ma biscuits, things like those. So you can determine by doing that. Command to make sure that you have to determine, because you still have drama 100 kwacha. Imene mukuyendekatu muyipange spend yonse kugulira ma biscuit komanso kugulira majani ma sweet. So to determine kuti ma biscuit atsala ngati, ma sweet atsala ngati, that doesn't matter. So to determine kuti ugule ma biscuit ochuka bwanji, ugule ma sweet ochuka bwanji, that's what we are calling optimization. So that optimization method that we are using to achieve this number of biscuits that we may buy is what we are calling linear programming. So in simple terms, tukunena kuti linear programming is an optimization tool. Ndi tool imene ingatithandizire kudziwa zinthu zimene tikuyenera kugula to make a profit, zinthu zimene tikuyenera kugula to make sure we have enough for what we need to have. Yeah, so I think reaching this far, we may go to another area. That is, if you don't have any question, I'll give you a few minutes for you to think about it. We are not going to solve, we'll just try to develop those inequalities. Sorry, I'm just trying this method of teaching live, if it can work. So basically my challenges to it tatu, komano those challenges will be tackled. So I hope that's that. This was the example. X greater than 5, y less than 4, 2x plus 3y, 25. So you can simplify it. This one can be simplified. You can say if you let 2 or 4 into 8, it will be 2. 4 into 12, it will be 3. And 4 into 100, it will be 25. So that's just a simplification. To simplify it is so you can say there it will be 2x plus 4 more 12, that's 3y less than or equal to 100, that's 25. So we'll look at another example and see how we can develop my inequalities from a given information. So you can take this time while I'm trying to get another example. But, in the target book 4, you can try problem and send me to WhatsApp, and I'll be able to answer. left on it. So let's take an interesting question, I think, which can also help us understand more. Okay, let's take this one. Let's take this one. For us, we'll not solve it. Solving it will be next time. For now, let's just learn how to come up with those equations. Linear inequalities. So for this one, they are saying a warehouse is to be built with spaces for dining tables and coffee tables. A warehouse is to be built with spaces for dining tables and coffee tables. A dining table occupies 3 square meter space, and a coffee table occupies 2 square meter space. And up to 240 square meter of space is available. There must be a space for at least 15 coffee tables, and the warehouse must have at least twice as many spaces for dining tables as coffee tables. So the first on this one, we want to answer question A because we are just trying to come up with inequalities. So in this one, we are given a problem. You can have a warehouse. A warehouse can be your sitting room. Kunyumba kwanu kwa sitting room. Now, the sitting room, in this case, mufunika muikepo choyamba dining table. Funa bakale dining table. Chachiwiri mukufuna bakale coffee table. So you have two things, dining table and a coffee table. But you don't know how many dining tables and how many coffee tables can fit your room. But you want to have as many dining tables and as many coffee tables as possible. So to achieve that, you need to optimize and see how many dining tables should I have in this room, how many coffee tables should I have in this room. But you have limitations whereby a dining table can occupy up to 3 square meters, while a coffee table can occupy up to 2 square meter space. Total space that you have is 240 square meter of space available. So you have other important issues. You are saying nowadays you need to have a space. In your space, you should make sure that mukalema table osajebera 15 for at least 15 coffee tables. Komanso, there is also another condition. The warehouse must have at least twice as many spaces for dining tables as coffee tables, which means dining tables should be more twice than coffee tables. So those alone are limitations. Those alone are your challenges. How do you make sure nowadays you sort out these challenges? It's by coming up with constraints, which are inequalities, So at a later stage, tikamazayamba kusolve these inequalities, we will be able to appreciate what do we mean when we say optimization. So in this case, we want to optimize the space that we are given. We are given 240 square meters, so we want to make a good use of that space. Tapatsidwa limitation onena kuti mukuyeneka mukhale 15 coffee tables. Musakhale ma coffee tables ochepera 15, which means pali zinthu zimene ma coffee table 15 akuyenera akagwira ntchito. Mukayikamo 14 ndiyo kuti ntchito ya imene ma coffee table amene akugwira isafala. But you need to put 15 coffee tables kapena ochulukira pamenepo malingana ndi imene mwazipangira optimize. The other limitation is whereby you are saying, okay, komanso my dining tables akuyeneka akhale ochuluka twice than my coffee table. So that's another limitation, which means the least you can have for dining tables akuyeneka akhale osachepera 30. Okay, so in this case, that is. So now let us see what they talk about a bunch. In this case, in simple terms, the coffee tables. Coffee tables. Then we have dining tables. That's the first thing. You are trying to understand what you are given. So from these coffee tables, each is occupying this is dining table, I mean. Sorry. Dining table is occupying 3 square meters, and coffee table is occupying 2 square. The total space should not exceed 200 square meters. Chifukwa warehouse yatu kukula kwache ndokoko. So you can't have ma coffee tables amene space yake ndi ma dining table amene space yake kupitirira 240. These are just arrows. These are not the symbols. Yeah. So this one is when as a so we need to give my variables. Coffee table is timpanga representation. Mostly we can either choose X or Y. So let's say coffee table is Y. Let's say dining table is X. So whatever you have has to be within this range. Now, the other area you have Y as coffee table, Y as coffee table, but this one, I want at least should be greater. This is by 15, at least. Okay. Y should be greater than or equal to 15. That's the first linear equation. Inequality, I mean, linear inequality, we can have from this. The second inequality is whereby it is in relation with dining tables. But in this case, they are saying at least warehouse must have at least twice as many space for dining tables. So we are saying dining table is X, so twice 2 times X. This one is also at least, which means that it have to be greater than or equal to coffee tables, which is Y. So this one is our second inequality. The third inequality that we can have from this one it's now that of determining, okay? whatever you are given should not exceed there. In this case, curve tables, you have y curve tables, and those y curve tables, that's representing the number of curve tables. If you multiply them by 2 square meters, will give you the total area in many curve tables will occupy. And this one should be added to dining tables. In this case, is x. So whatever you do, x represents the number of dining tables. So if you multiply by the space you have, the number of dining tables, if you multiply by the space you have, so it will be 3x. Whatever you have should be less than or equal to 240. Okay, so either way, you can start with x. You can say 3x plus 2y should be less than or equal to 240. So this is our third inequality. So in linear programming, for you to survive in linear programming, it's a matter of understanding how you break down this information in many parts up. If you know how to break down this information, the rest is makazosavuta. Yeah, so this is the only time that I had. I said I would start at 8 o'clock and finishing at 9 o'clock. Now it's 08:59 p.m. Very soon to be 9 o'clock. So let me end this lesson here. You can send mafunzo WhatsApp. You can send mafunzo here. I'll be able to respond to them. The first part I will announce and possibly announce and possibly share and have anything that kudzapitiriza on how to solve my inequalities tabanga teachers. Thank you. I'll stop recording now.